a function. If we wrote this as points, this would be 1, 2, and 1, 4. Notice that the input of 1 is mapping to 2 different values. So this does not pass the vertical line test. We can do this just visually by sliding your pencil vertically across the graph. Here it fails because at 1 there are 2 different outputs. So no, not a function, because it fails the vertical line test. Here's one more. Graph to show you. One, 2, 3, and 4. 1, 2, 3, and 4. This one has a point at 2, 1, 3, 2, 2, 3, 1, and 4, 1, and this one's actually continuous. This is a portion of a sine curve, just for fun. You'll get to that when you do trigonometry. So let's take a look at this. Again, this is the y-axis, and this is the x-axis. Those are always the same. Let's look at the domain. The domain is all the possible input values. And it's a set, so we're looking at the x-axis. Now, instead of being single points, this is continuous. So on the x-axis, it starts, the lowest point is at 0 right here, and it goes all the way to 4. And there's a point along each part, or above each part of this x-axis. So we did inequalities last chapter. We're going to write an inequality starting at 0. And there is a point at 0, so I'm going to include 0. 0 is less than or equal to x, because we're on the x-axis for domain. And it ends at 4. And I'm going to include 4 as well with that little equals to, because there is a point right here at 4. So the domain is from 0 to 4. There are points on the x-axis all the way from 0 to 4. And we're going to write that as an inequality. For the range, now we're looking at the y values. So looking at this axis right here, this vertical axis, the lowest point I see on this vertical axis looks to be at 1, right there. And it is including 1 because there is a point, a closed circle at 1. So 1 less than or equal to y, we're talking about the y values for the range. And it goes all the way up to 3. So 1 to 3. And again, we're including 3. There is a closed circle at 3. So we're going to write our domain and range as an inequality. Last question is whether or not this is a function. Since it's a graph, we can run our pencil along it for the vertical line test. So starting right here, I do hit the graph at exactly 1 point, exactly 1 point, exactly 1 point, all the way across. So I do not see any point where there are 2 parts of the graph right on top of each other. So this is a yes, because it passes the vertical line test. Now, those are the 4 ways that you can represent a relation: through a list of ordered pairs, through a table, through a mapping diagram, and through a graph. You could represent the same relation all of these 4 ways, just different representations. The last thing I want to talk about here in 3.1 are independent variables versus dependent variables. And this is just another vocab word to describe the same things that we've already been talking about. The independent variable, that's the vocab word. Independent meaning the input value. Input value or domain, which again is typically the x's. We also have the dependent variable. Then the dependent variable depends on the independent. So an independent variable would be something like time. Time is independent. It's going to keep ticking at the same rate whether we like it or not. Dependent could be cookies that we're baking. How many cookies can bake in a certain amount of time? That is the output values, or the range, which is typically y. Sometimes we use other variables, but usually we use x and y. So the dependent variable, the y values, depend on the independent or the x. So let's show one example of how this plays out. We'll call this example 2. For example, the function a equals -4b plus 14 represents the number a of avocados you have left after making b batches of guacamole. And I love this problem because we make guacamole all the time, even if it's not Taco Tuesday. After making b batches, so we're talking avocados and batches of guacamole. So we've got A avocados and B for batches. We want to do two things. The first thing we want to do is identify the independent and dependent variable. Independent and dependent variable. And I'm also going to give you that the domain is 0, 1, 2, and 3. And I want you to find the range. What is the range? If you need to pause the video to make sure you can get down all of this example, I recommend you do so. We're going to go ahead and keep moving. A, we need to identify the independent and the dependent. Now we can think about this logically. Would the number A avocados depend on how many batches we've made? Or would the number of batches we've made depend on how many avocados we have left? To me, it makes more sense that the number of avocados we have left depends on how many batches we've made. Now, if that doesn't seem as obvious to you, another way to check is that the variable embedded in the expression on one side of the equal sign is usually the input, or the independent variable. So that variable embedded on this side of the equation is the input. The variable that is solved for is the output. So what this is saying is we take b, the number of batches, we multiply it by -4, and we add 14, and out comes this number, which represents the number of avocados we have left. The output is dependent. The number of avocados we have left depends on how many batches we've already made. So the number of avocados left depends on the number of batches we made. Logically, I think that makes sense. The other way seems a little more ridiculous. Therefore, A would be our dependent variable. Number of avocados left depends on B, which is the independent. That would answer part A, identifying independent and dependent variables. Part B is asking us if the domain is 0, 1, 2, and 3, what is the range? So an easy way to organize this would be to make a table. I've given you the domain, which matches the input. Remember, domain goes with input, which means I gave you b values. B values in the domain. And those b values were 0, 1, 2, and 3. Now what this function is telling me to do is multiply -4 times each b and then add 14. And what that equals will be a. So I'm taking this messy part of the formula right here, and I'm just moving it down in my table. For my first element in the domain, I'm just going to plug that b value right in there. And my output will be a, which will also give me the range. So -4 times 0 is 0. 0 plus 14 is 14. You can do this in a calculator or in your head. It is up to you. -4 times 1 is -4. -4 plus 14 is 10. Now I'm going to plug in 2. -4 times 2 is -8. -8 plus 14 is 6. And last but not least, we're going to plug in 3. -4 times 3 is -12, plus 14 is 2. Therefore, this list of a values, these outputs that I got from inputting all of my b values in the domain, becomes my range. So my final answer would be the range is the set of, and again, increasing order, so I'm going to actually start with 2. The range is the set 2, 6, 10,